Hi guys, let's work on section 5E, correlation and causality. I know it might not be quite as bright this time, but hopefully you guys can all see it as well. Working on some lighting issues here. Okay, so now you have the 5E worksheet. Let's read through it together. In each of the problems, 1 and 2, state whether the diagram shows a positive correlation, a negative correlation, or no correlation. We're going to talk about what all of those mean. And then if there is a correlation, is it strong or weak? And summarize any conclusions you can draw from the graph. So let me give you an example. If I have a graph that looks like this, I'm not going to label the axes right now, and I have a bunch of dots on the graph kind of together, something like that. Okay? If I have a graph that looks like that, it's a little tough to see, but hopefully it's okay once it's on your computer screen. I would say this has a strong correlation. It's strong because these dots are very close together. Okay, all of the data kind of is in the same general area, so it has a strong correlation. I would also say this has a positive correlation, because if you were to plot a line in here, it would go uphill, right? We kind of read math from left to right, so it would go uphill, so that would make it positive. If I had a graph that kind of looked like this, something like that, you can kind of see how all the lines are going downhill. That would definitely tell me that it has a negative correlation. Okay, when the line, if you were to plot a line kind of in between all these dots, it would go downhill, so it would have a negative correlation. And I might say this has a weaker correlation than before. It's a little bit weaker than the last one, right? The lines are kind of close together, but they're also kind of spaced apart. If I had a bunch of dots that kind of looked like this, and they were all kind of like randomly scattered, I would say there's no correlation there. There's no correlation. They're not really related. Correlation. They're not really related in any way. There's no correlation because they're just kind of all over the place. And if there's no correlation, it can't be positive or negative. It's just none. So let's look at the examples that they gave us on the worksheet now and apply what I just showed you there. So the first graph they give us is about the US presidential elections from 1964 to 2016, and they're talking about unemployment and voter turnout. So would you say there is a positive correlation, negative correlation, or no correlation with number 1? What would you say, and why would you say that? On the test, I'm going to ask you a lot of why, because I'm going to want your explanation, because I think there are a couple arguments that could be made for number 1. So what would you say and why? It's a tough one. I would probably say there's not really a correlation. There's a bunch of data that is, kind of at the beginning of the graph. Let me see if you can see this here. I have a giant lamp in my way now, so that's a little tougher. There's a bunch of data at the beginning of the graph that kind of starts to go uphill, and then it almost kind of goes downhill after that, but these dots are kind of just all over the place. So I said none for that one. If you said positive or slightly positive, I would also say that could be correct. And then in terms of why, you could say, it looks like the data kind of goes in a positive direction, right? It kind of goes uphill. And I said it was a weak correlation. So when all of those dots, we talked about it, when all of the dots are very close together, it's a strong correlation. And when they're kind of farther apart, it's a weak correlation. I would say this one's pretty weak. But look at number 2 now, especially versus number 1. We should have done number 2 first. What would you say about number 2? Is there a correlation? Is it positive or negative? It's negative, of course, right? Those dots start up high and then they go downhill. It's definitely negative. And is it strong or weak, number 2? It's definitely strong, right? All of those dots are pretty close together, and you could almost plot a line that would touch or be very close to touching a lot of those dots. Good. So number 2 is negative and strong. And just a reminder, number 1 is either none, or maybe you could make an argument for slightly positive. I mean, it's also a weak correlation. Okay, good. What about the next ones? For the following pairs of variables, State the units that might be used to measure each variable. Then state whether you believe the two variables are correlated. If you believe they are, if they're related, if they're connected, correlated. State whether the correlation is positive or negative and explain your reasoning. So what about number 3? The height of a person and how frequently he or she attends religious services. Do you think those two are related in any way? No, of course not, right? Anyone could be any height and go to church or services or not, right? That one doesn't even really make sense, right? You wouldn't think of any relation there. So that one would be they're just not correlated. The height of a person has nothing to do with how often they're attending religious services. Good. What about number 4? The age of a person and the time spent on social networking sites. So if we wanted to actually make a graph of number 4, it would kind of look like this. We would put their age down here, and we would put their time on, what do you guys use now? Do you use Insta? Time on Instagram up here. So when people are very young, so here's, let's say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. What do you think? When people are less than 10, do you think they spend any time on Instagram? No, right? They don't have Instagram accounts. They'll all be right at about 0. What about in their teens? Do you think the time goes up to a lot? Yeah, sure. 20s, 30s. Maybe it starts to drop. 40s, 50s, 60s, 70s. Might kind of look like that, right? Eventually, right, it has to go up. So what would you say about that correlation? And you could make arguments, or you could draw graphs that were slightly different. But what would you say about that correlation? I would probably say that it's probably pretty strong, right? I bet a lot of these dots would be pretty close together, right? 20-year-olds, probably something like this, but some people don't spend any time on Instagram. Same thing with 30-year-olds, we're probably up here, but some people don't. Same thing, probably a lot of people up here, and then it goes down, might even go down sharper, like that. But I would say it's probably pretty strong, and I would say it's mostly negative. It's positive at first and then goes down, right, to mostly negative. Again, you could definitely make exceptions, and a good way to kind of explain what you're talking about in number 4 would probably be to draw a graph, just like that. So the age would go here. So as they're 20, they're spending more and more, time, and then it starts to go down, most likely. Again, I'm making a lot of assumptions here, but that's kind of what we do with statistics, which is what we're talking about. All right, that's number 4. Again, if you have any questions, feel free to email me. Love to hear from you anyways, even if you don't have questions. Let's look at number 5. The altitude on a mountain hike and air pressure. Altitude, right, means as you're going up on the mountain. So as you're going higher on the mountain, what happens to air pressure? It drops, right? So as you're going higher, so as your altitude keeps getting higher, the air pressure is dropping. That one would definitely be a negative correlation, and it would definitely be very strong. The air pressure drops as you go up in elevation. What about number 6? Average property tax in a town and average salary of its residents. What do you think about number 6? How are they related? Are they related at all? Maybe, right? Maybe. I would say that the average property tax is going to go up as the houses get more expensive, right? If you have a very large, expensive house, you're going to be paying a lot in taxes for it because you're taxed, right, a certain percentage on, every $1,000 or whatever your house is worth. So if you have a lot of, $500,000 to $1 million houses in a town, the property taxes are going to be they're going to be higher, right? The average salary of its residents would probably have to be high as well. If you're paying a lot in taxes, you have to be able to afford it, right? So I would say those two have a strong correlation, generally. And I would say it's probably, it has to be positive, right? As your house is more expensive, you have to be making more money or getting money from somewhere. Generally, you're making that income. Again, we are making generalizations here. There are always going to be exceptions to all of these different situations, but we have to kind of make generalizations. This is exactly what they do in stats too, right? Like statistically, this person is the most likely to do what? Of course, there are going to be exceptions, but we have to make a lot of generalizations to account for the majority of people. So if those ones don't make sense, please just reach out to me and let me know. Let's look at number 7. I gotta check my time. I'm having trouble uploading videos that get too long, so okay, we're good. Hopefully that light isn't too distracting either. I know I can see it here. Let's look at number 7. Make a scatter plot. So I want you guys to go ahead and pause the video. If you need help with the scatter plot, you can feel free to look on, but I want you to try this because you may see one like this again on the homework, and I'll start you off. But go ahead and pause the video and make the scatter plot. I would put the literacy rate as your x-axis and the infant mortality as your y-axis. So make the scatter plot like this. Put the literacy rate here and put the, what else is it? The infant mortality here. And go ahead and space them out and make the graph. Go ahead and pause the video and I want you to try that now. Go. Okay, welcome back. So for literacy rate, of course, it can only go up to 100. So I'll put 100 here. I'll put 50 in the middle. I'll put 25 here. This isn't, hold on, let me fix this. This looks terrible. I'll put 25 here and I'll put 75 here. Infant mortality goes up to about 152, so I'll put 150 here. Well, no, 2 more is just a little. So this is about 50 and about 100. This is a little bit of a morbid subject, I know. So we can plot each one. So Afghanistan, the literacy rate is just over 25%, and their infant mortality rate is very high, which means infant mortality rate of 152 means that out of every 1,000 births, 152 babies die. So what about Austria? Their literacy rate is 98%, we're way down here, and their infant mortality rate is only 4. So it's about right here. So these are my 2 points on the graph so far. So Afghanistan, Austria. Let's do Burundi. That's 59% is their literacy rate, and their infant mortality rate is 60. So we're about right here. You might be tempted to make some assumptions, but I would definitely plot a few more points from that. I'll keep going. I'll do Colombia 93 and 19. So we're about here. And then I'll do Ethiopia. That's 43 and 81. So we're about here. And you can already start to see what's happening. 99 and 4, that's about here. And then you see 58 and 138, that is about here. 99 and 5, that's about, oops, right about there. 87 and 26, that's about, oh, here. And 99 and 6, that's about right here. Okay. So what do you think about this graph? Is there a correlation? Yes, of course. You'll notice all the dots kind of trend the same way, and they're all fairly close together. So yes, there is a correlation. Is it positive or negative? It's negative, right? The line kind of goes downhill. Does it appear to be strong or weak? I would say pretty strong, right? Most of the dots, if we wanted to draw a line, we call this in stats, and we're not going to talk about it much, but a line of best fit, right? I could pretty much draw a line right here, and most of the dots are, oh, that green doesn't work. Most of the dots are pretty close to that line. Oh, how did that marker already die? I didn't even use it. Okay, so negative correlation, it's strong. And then they ask us, do you suspect causality? Do you suspect causality? Meaning, does one of these things cause the other one? Sometimes you can have things that are actually correlated, but they don't cause each other. There's a funny website. I'll try to remember to attach it to my 5E email, which is probably the one you already opened, which is why you're on this video. But it's an interesting website. There are funny examples on there that I think are fun. So what do you think here? What do you think with this? Does one of these things, does the literacy rate have something to do with why babies are dying? What do you think about that? Yeah, it's people are able to read more, right? As the literacy rate approaches 100 and most of the country is able to read, what else happens? They're able to become more educated, right? Maybe there's more financial, abilities, more financial resources to them because they're either educated or, maybe they have jobs or something like that. So as they're able to become more educated and able to read more, it could be that the infant mortality rate gets lower, right? They're able to educate themselves. Maybe they, have an educated system. Maybe there's a good healthcare system in place. Maybe it's a developed country, right? It's a lot easier to keep babies alive when you have, hospitals that are top of the line and stuff like that. So yes, I would say these two things are related. Let's look at numbers 8 and 9, and then we'll be done. This is a pretty short section. I'm going to erase the title. Go ahead and read through them. They want us to describe the kind of correlation. Is the correlation most likely due to a coincidence, a common underlying cause, or a direct cause? And there's that word again, explain. Okay, what about number 8? When gasoline prices rise, sales of sport utility vehicles decline. Number 8. What do you think? Do those have anything to do with each other? Probably, right? We might call them inversely correlated. As gas prices go up, what do you think happens with sales of sport utility vehicles? Or I guess it tells us they decline. Right, that makes sense. As one thing goes up, as gas prices go up, the sales of the sport utility vehicles go down. Why? Well, it's just common sense, right? People don't want to pay for all the gas for those SUVs. So we could say there's a direct cause there. There's a direct cause. And it's just as simple as people, don't want to pay for gas. Pay for gas. Sure, that's a great answer. What about number 9 then? In a large resort city, the crime rate increased as the number of taxi cabs increased. What do you think? In a large resort city, the crime rate increased as the number of taxis increased. Is that a coincidence? Probably not. What do you think? What about a common underlying cause? What could those two things have in common? More taxis because maybe there are more tourists, right? So the crime rate also went up. So maybe as tourists, start to flock to a region, well, you need more taxis, or I guess now we should update this, Ubers and Lyfts, right? But as there are more tourists, there's more Ubers and Lyfts, so now the crime rate goes up just because there's more opportunities, right, for whatever crimes that are being committed. So I would say that one has a common underlying cause, and that's that there are more tourists, so there are more taxis, so there's more crime. That would be a good answer for that one. Good. Well, that's it for 5E. If you have any questions, let me know. The next two sections we're going to do are 6A and 6B. And then after that, your test will be due at the end of next week. So not this week, but next week. Your test will either be on, I don't have the dates right in front of me, of course. I believe it's either the 16th if you're the Tuesday, Thursday class, or the 17th if you're the Monday, Wednesday, Friday class. So make sure to please, I know you guys are doing your best. Me too. Check the dates on my math lab just so you know ahead of time. Oh yeah, I have to make sure I watch the video and then get the my math lab section done. I've been kind of lenient because I know we're all learning new things here and we're all in a whole new world, but please try to make sure you're good with the my math lab and have it due when it's due. We have only another month to go and then we're done. But if you have any questions or you need anything, let me know. I hope you guys are doing well and I hope you're staying healthy. See you later.